Today we're going to talk about linear inequalities.
Wow.
All right. So, graphing an inequality. We need to make a sketch of each of these. So, on your paper, if you would write each of these with space next to it so that we can graph this. Some teachers are super picky about how much detail you put into a number line graph. I am not one of those teachers. I want to see that you have the numbers on the number line in the correct numerical order. So if we're dealing with something like -3 and 1, this number is -3 and this number is +1. -3 definitely needs to be on the left side of 1 because -3 is smaller than 1. If you want to put more detail, if you want to put in -2, -1, 0, 1, you can, but you do not have to if you do not want to. Okay, quick little recap. If it is one of these symbols, less than or greater than, you use an open circle because it's not equal to, so the shading can't be on that number. Shading indicates that it can be that number. So if it's not equal to, it can't actually be that number. It's everything up to, but not including that number. If we have these symbols, we need to use a filled in circle because the shading includes that number. So at -3, between -3 and x is the shaded stuff, there's a less than symbol. So that means at -3, we need an open circle. Between x and 1, it says less than or equal to, so this thing can equal 1. We need a closed dot at 1. Do you see how x is physically between the -3 and the 1? The shading is between the -3 and the 1. The symbol is eating the x, so x, the shaded stuff, needs to be bigger than -3. The shaded stuff also needs to be smaller than or equal to 1. So everything between -3 and 1. For B, we're doing -3 is less than x. It's not great to write your inequalities like this. You really want the letter to be written first because then there's a really fun shortcut for how to shade. If it's written like this, you really have to think about what this means. So we can tell that this needs to be an open circle. The shaded stuff, the symbol is eating the shaded stuff, and that symbol eats the bigger thing. So the shaded stuff needs to be bigger than -3. So which direction will we need to shade?
Right.
To the right. It'll pop back up eventually, I'm sure. The other thing that you can do is switch this around. Write the x first and the -3 second. The symbol is eating the x, so make sure your symbol is eating your x. If you rewrite it with the letter, with the variable on the left side, then the symbol actually points in the direction that you need to shade. A greater than symbol is like an arrowhead, and if you turn it into an arrow, it's pointing which direction you need to shade. But that trick only works if you have the letter written first. And honestly, you can remember the trick, or you can just think about what it means. So if x is bigger than -3, x is the shaded stuff. The stuff bigger than -3 needs to be shaded.
Okay, because I was confused. I didn't know if it was like a matter of how we shaded it.
This next one, x is less than or equal to 2. So we've got a 2. Some people like to also put 0 on the graph so that you can see like a little bit more, but I really don't care about how detailed your graph is. Should we use a closed circle or an open circle on this one? Closed circle because it can equal 2. And x is less than or equal to. It's eating the 2. That means 2 is bigger than the shaded stuff. So we need to shade where the numbers are smaller than 2. And you can use zigzags, you can shade using scribbles, just make it obvious that it's like shaded in one direction or the other.
Ooh, mine kind of looks like sound waves.
Solving linear inequalities. This time we need to solve and then graph the solution on a number line. So solve this just like an equation. There's just one tiny little trick. Do you remember the trick with inequalities? You flip it when you multiply or divide by a negative. If you don't multiply or divide by a negative, you don't flip anything. So on A, we would need to subtract 3x on both sides or subtract 5x on both sides. It really wouldn't matter. And then we would add 7 on both sides. And then divide 2. So x is greater than 8. And then sketch yourself a little graph. Put 8 on there. Should I use an open circle or a closed circle?
Okay.
Should I shade left or right? All right, try B on your own. If you're watching the video, pause the video, try B, then play the video again. Don't just stare off into space. Actually, try some math, please. Pause the video. If you haven't paused it yet, you need to pause it. Pause it. So I subtracted 4 on both sides and got negative x over 2 is greater than or equal to negative 7. Keep in mind when you get rid of this 4, that negative is still part of that fraction. To get rid of the negative, I'm going to do this in one step. Basically, I'm going to put the negative with the 2. It doesn't matter where in the fraction the negative is. It can be on the top, it can be in front, it can be on the bottom. For us, it's going to be most helpful if it's on the bottom, because how do we undo divided by negative 2? Times negative 2. And when we multiply by a negative, we have to flip the sign. So this becomes x is less than or equal to positive 14.
You said why do we flip the sign?
Anytime that you have to multiply or divide by a negative number. So because we multiplied both sides by negative 2, we had to flip our sign. No, I didn't want to go to the next slide. I was just trying to highlight something. Come on.
Flip sign when you multiply or divide
By a negative number. Okay, less than or equal to 14. So we need a closed circle. And less than, so smaller than 14, that would be shaded to the left. Okay. Take a moment and write this example down. 0 is less than or equal to 3x minus 5 is less than 1. I'm actually going to rewrite it. This type of inequality, basically treat it like there's just 3 sides. The goal is to get just x in the middle. So whatever you do in the middle to get x by itself, you have to also do on the left and on the right. So we are going to add 5 to all 3 sides. So 5 is less than or equal to 3x is less than 6. Then to get x by itself, what do we need to do? Divide by 3. We have to divide everything by 3. Should I flip any signs? Why not? We divided by a positive number, so we're good. We have 5/3 is less than or equal to x is less than 2. Now, for ease of solving, you can leave that as 5/3, but when you need to graph it, it's really helpful if you know what decimal 5/3 is. So what decimal is 5/3? 1.67. So here's 5/3, or 1.67, 1.6 repeated. No, I don't want to go to the next page. Come on now. And then over here is 2. At 5/3, our symbol is less than or equal to, so that's going to have a closed dot. At 2, what type of circle? Open circle. X is literally between these two numbers, so we are going to shade between these two numbers. All right, this one, I'm going to rewrite it so I can actually work on this. -5 is less than or equal to 3 minus x. That whole thing divided by 2 is less than 4. Okay. Step 1, do you see how that's a big, long division bar? How do we undo divide? Multiply. We are going to multiply everything by 2. Yeah. Okay, when I multiply by 2, and I probably should stick it right here, multiply by 2 undoes the divide by 2. We have -10 on the left, 3 minus x in the middle, 8 on the right. Question: should I change the signs? No. I multiplied by a positive number, so we don't change the signs. Now what? Subtract 3. What's left in the middle when I subtract 3? -x. We've got -13 on the left and 5 on the right. No, I don't want to go to the next slide. Come on. Okay, how do we, oh, have I changed the signs? Nope, my signs are still the same. How do we get rid of that negative in front of the x? Divide by -1. Now, because we divided by -1, we have +13 is greater than or equal to x is greater than -5. So because we divided by a negative number, we have to change the signs. And really, look at this. Doesn't this make sense? -5 is the smaller number. 13 is the bigger number. These signs have to eat the bigger number. So doesn't it make sense that the signs are pointing the opposite direction now? Okay. Now, before you try to graph this, this is not going to be very much fun to graph, because here's what you're going to end up doing. You are going to end up saying 13, -5, closed circle, open circle, shade in the middle. Is that number line correct at all? No, -5 has to be on the left. But I know that some of you get the answer and then just throw it on the number line and call it good without really looking at what you're doing. You've done that before, haven't you? So the best thing to do is rewrite it with the smaller number on the left, the bigger number on the right, with x in the middle, and then just transpose the symbols. Basically, you're taking this and flipping it around, but between the -5 and the x, the sign was eating the x. Between the x and the 13, the sign was eating the 13 and had an equals line underneath it. Once you get it rewritten like that, then you can kind of mindlessly put the numbers on here. Open circle at -5, closed circle at +13, and shade in the middle.
That is a lot.